Hello and welcome to the session where we're going to review some of the updates and some of the upcoming components and new features available in the NanoStream Blue component suite. So just to review again, the attendance manager, there is a new component to this. So we have, as we specified last time, the ability to control our groups and the roles in the groups, and we could control the events associated with the group. We could edit the members in that group, and we could edit the roles in the group. Then, of course, in the registration part, you would basically register yourself as present. So if you register yourself, then you go ahead and you search for your event, and then once you've found your event, you go ahead and enter the PIN that's provided by the organizer. And if you are in the role of an organizer, you could manually go ahead and register any member for any of those events as well. So under the attendance part, we could look at the statistics. So that tells us for the various groups the attendance rate, and we could look at how that changed with time, and we could look up particular attendees and their attendance rate. And then what's a bit new now is that we have this calendar. So all the events will populate in this calendar, and you can go ahead and page around in the calendar, and you can edit all the events here as well. So this would work quite similar to what we're used to seeing in Outlook and other email clients. So you can go ahead and edit your events more directly here. So that's basically the new part in the attendance manager. And then in terms of other new components, we now have the concept scaffolding part. So in concept scaffolding, we create a set of nodes, and then we define the relationships among nodes. And the application here, as you see, is for concepts. So when we have a curriculum, for example, and we are trying to establish the relationship among concepts in a course or even among courses, we can create a list of all the concepts. So we just list all our concepts, and then we have an editor that lets us associate any concepts together. So for example, here under limits, we find that all these topics come out of limits. And if we click on one of these, for example, derivatives, if we just find that here, so then you can see limits was not the only parent concept to derivatives. Also trigonometry can play a role. And then in terms of the concepts that come out of that, so you can regard the topic as being a prerequisite to the children. So the concepts, the later concepts that come after this topic has been understood are listed here, and it's all shown graphically here. So, and it's quite fun to go ahead and drag around any of these nodes. But anyway, you can see here the two blue ones pointing in, those are the parent concepts. And then once those are well understood, then that concept can be understood, and then that can play a role in these other concepts. And of course, these concepts may have other parents as well. So if you go ahead and choose, for example, differential equations here, differential equations, which is here, then you can see differential equations actually has quite a few parents. So you can see the arrows all pointing towards differential equations, and also we use the color to signify that. So differential equations has 8 parents and 2 children. So we are showing you can do partial differential equations, you can do integral differential equations as well. Once you understand differential equations, and to understand this really well, you need to understand all these concepts. So limits, linear algebra, trigonometry. Well, I'm not saying this is done very rigorously. It's this is more to illustrate the graph nature of the setup, and of course that can all be discussed further. It should be noted that you can maintain multiple scaffolds. So fine, we can have a list of all the concepts, but it doesn't have to be the case that there's only one one way to create those parent-child relationships. You can maintain multiple trees even though the set of nodes are common. Anyway, more about that in an upcoming video. So for now, we can create a set of concepts, we can create relationships among concepts, and we can illustrate it graphically, and we can implement with editors so that we can completely create a view of all our concepts and so on. So concept management is important in curriculum development. So once we understand our concepts well, once we're able to edit our concepts, then we can form a picture of the way concepts are cross-connected across an entire curriculum. And you can imagine an application of this in a classroom. So for example, if you are starting to teach this topic of geometry, well, that's a very broad one, but anyway, let's say we are just starting to teach this concept, then it's quite easy for us using this to say to our students, well, you need to really understand these blue things well as prerequisites. So you need to possibly revise these topics before you can really understand this topic well enough. And then the relevance of this topic, right? It's important to study this topic because now you can see all the other fields that become accessible to you once this topic is understood. So that's one application, just being able to concept map to students for teaching purposes, for motivation purposes, and for understanding the revision needs. So that's one application. Another one is, of course, what's shown here is biased towards our choice here. So every time we choose a new concept, we see everything specific to that concept. But of course, we can generate these maps for all concepts together, and then that in effect shows us how the whole curriculum is cross-connected. And there we can use our graph theory. So for example, here we have some simple metrics from graph theory. It's showing us the degree, that means how many neighbors of this concept limits we have, and what proportion of that or what number of that are children and what number are parents. So just those simple metrics start to tell us how the graph is cross-connected. And there are many other metrics for a graph that we can implement and use those to understand a curriculum. We can understand if concepts are being taught too far away from the point of application. We can understand if a concept is being taught after it is actually being applied. So there are many applications to curriculum design through a graph theory approach. So that's our concept scaffolding, and then looking on to assessments. Right, once we have our list of concepts, we can attach to that list of concepts all the resources for the concepts, but we can also attach assessments to our concepts. And here we are showing an assessment. So here's a kind of chemical engineering type of question. What's a CSTR? And the correct answer is continuous stirred tank reactor, but I'm just going to choose the wrong one here. Then the CSTR is known to be the worst user, and you can say here because the concentration is the same everywhere. And then if the CSTR is fed by that, and so it's let's just choose an answer at random here. And then a Bentley is accelerating after, and let's choose something there, and we'll choose something there also. So we have 5 questions here, and there's a bank of just 4 questions, so this question has been repeated. But anyway, if we click practice, then it's going to give us some feedback about where we've got the answer right. So here, what does CSTR represent? Yeah, so that was wrong. Continuous stirred tank reactor, that's the right answer. And you see here, the question has repeated here, but the answer is in a different position. So it is shuffling the position of these multiple choice answers. So if you click there, you see now I've got that one right, and we hadn't changed that, so that's still right. And then here, CSTR, so now this one requires some calculation. And you'll see just now that these numbers are not fixed. So these numbers are being randomized, and here, let's see, so this one is close to 4 divided by that, so it's about 0.5. And if you look here, there's something close to 0.5. And then if you're accelerating 23, the units, the units are not right here, but anyway, so 23 and 30, so that's the right answer. And if I say practice again, then you'll see I've got more of these things right. There is one answer which requires grading. So we are not able to auto-generate a test of this answer. So it requires a teacher to go ahead and grade that particular problem. So if we say submit for grading, then that's going to bring up all our answers, and it's giving the teacher the option to provide a grade for this answer. So if you say, whatever it is, and write a comment, and in fact you might write something to give a bit more detail on this answer that has been submitted. So you might write about instead that you are right or wrong for these particular reasons, and then you go ahead and click grade, and then that tells the recipient what grade was received and what the comment was by the grader. And so now the student has all the results available. So how do we set this up? So if we go over here to the assessments editor, you can see this is our pool of questions. So we have 4 questions here, and then our assessment config is here. So we can provide a title to our assessment. So you'll see here that was our title. And then session length means the number of questions that we want to generate. And this can be larger than the number of questions in the pool. So we only have 4 questions here. You can see one of those questions was repeated. This one was repeated. And if we had increased that further, more of the questions would be repeated. However, there's a lot of variation in these questions because, for example, the text itself can change, and the numbers behind the question can also change. And we do that here. So in the editor, we've looked so far at setting up the assessment. Then here, we are also editing the question. This should say question config instead of assessment. But anyway, so for this one, here we can change the label. And now you'll see these angle bracket tags in here. So molar flow rate, conversion, reaction rate. So you see, instead of numbers, we have what looks like a tag. So for a CSTR fed by something exhibiting conversion something. Let's look at what we have here. So for a CSTR fed by 5, and we should write something like moles per second in there. So we can provide the units in the text, which you would do here. So molar flow rate, and we can just write here moles per second. I'm not going to update that yet, but anyway, you can write your description of the question here, and then if you want to include variables, you do that using these angle brackets and then the name of the variable you want to create. And the place that you create those variables is here in variant data. So in variant data, you can define as many variables as you like. So here you'll see I've defined just 4 variables: rate, molar flow rate, conversion, and volume. So volume is what the question is asking us to work out. And now to randomly generate solutions, we also have to do a calculation on the output variable, which is the volume. You'll see also that in our question, we are also specifying a solution. So in and amongst the settings for this question, we have to specify a solution. We specify what score we allocate to a solution, to this solution, and we specify some text. So this text gets used when the reader wants some feedback. So if we go back to our test here, let's say we chose the wrong answer, and we say practice. So here it says we didn't get the maximum score. Our answer was 8, but that's not the right answer. And to get the maximum score, we have a little explanation here. So using equation this, we have that, and so the calculation turns out to be 0.47. And so that tells us that should have been the answer that we choose. So now that we have the right answer, it doesn't give us that comment anymore. So you can imagine this is quite valuable for students who are practicing problems. So if we have a nice big pool of questions, then and if we have enough variation implemented into our questions, then the students can keep practicing and improving their performance. And then we just have to figure out how to do that, how to implement this variation. So as I say, you can create a field, variant data, and you can create the variables. And then in creating these variables, we have to specify how the calculation works. So by the way, you don't specify function here, just remove that. So you specify a new attribute, so like rate, molar flow rate conversion. And then in here, you specify func, and you specify what the function must do. So in this case, it turns out that there is available a function, so get rand int, so you just have to know that that function is available. So if we want to get a random integer between 1 and 10, you use that. If you want a random integer between 5 and 9, you use that. So that's one way you can create a function, and this works using JavaScript, so you can use any JavaScript code in there that returns some answer for you. Alternatively, instead of specifying, so conversion is yet another variant variable. So instead of specifying a function, you can just specify an array. So in the case where you just specify an array, then of course the system is just going to randomly choose one of those elements of the array. So conversion, the available options are just 0.25, 0.5, 0.75. And if you look here, you can see it's got the 0.75 there. So it's generated a problem. It's generated a number for that case. And if we go back here, right, and the rest follows. So those are how you define the variables. Now, it's not enough just to define variables. You then have to also define the possible answers, and that's shown down here. And so, by the way, for each question, we can define as many answers as we want here. So let's just look at that problem. So the available answers here, so this first one, we specify a score for choosing this answer, and we specify a value. And here you see again, we've used the variant tag. So we've specified that the value of the answer, if we choose this answer, is volume. And we also have a label here. So label is what gets shown on the screen, and value is what gets used in doing the calculation on the score of the student. So label is just what we see here. So if you look here, you can see it's showing the unit. So the cubic meters is shown here. And then when the user chooses that option, what actually gets sent for evaluation is the value volume, so without the units shown. So label, value, and score, that's really what you want to do. You can also specify which question this answer belongs to. So of course it belongs to that question, so that's why that code's there. And the rest we don't have to interfere with. These are the really important bits, right? So that's how you create this answer. So this answer is using the volume. So the volume is of course created inside of the question variance. So if you look in your question variance, you'll see volume here. Now volume is being calculated. I'm just going to remove this thing. Volume here is being calculated from the other variant values. Now the question becomes, how do you get these variant values inside this function? And here you can assume that all the variant values that come before this variant statement, all those other ones are available within the wrapper of vals. So when the question is generated, it sends, each time it tries to figure out what value to use for the variant, it sends in all the existing values. So all these other values have been generated. We have generated a random number for rate. We have generated a random molar flow rate value. We've chosen one of these three values for conversion. So all those values now exist by the time we come to calculating for volume. So we assume all those exist within the wrapper of vals. So if we say vals.molar flow rate and vals.conversion and vals.rate, we assume all those have numbers now. And so we write a function, and this time instead of specifying known ranges, like here we had a known 5 to 9 or a 1 to 10 or one of these three, this time we are not specifying any known number. Now we are referencing the variables in the other, as one of those variants. So we specify the variables, and so we in effect calculate a value for the volume. So that's how you do this. In your variance, that's where all the action happens. That's where we do our calculations to generate everything needed to both ask and answer that question. So in asking that question, we needed these variables, right? And then to answer the question, we need this variable, the volume, because that's what the question is about, right? It's asking for the CSTR fed by that and that, what is the volume? So we need to know what the volume is before we ask anybody else what they think the volume is going to be. So, so we calculate that as a variable. We also calculate an additional variable here, INV volume, the inverse of volume. So that's because you might have some question, or you might have some misconception that volume is calculated by dividing the rate by the molar flow rate times the conversion. So this is not correct, but we want to probe our assessmentees. So the people taking the assessment, we want to probe whether they know that the correct calculation is flow rate times conversion over rate and not rate over flow rate times conversion. So we provide that as an option also. So we do a calculation to work out the wrong answers as well. And so in creating our options, right? So in our answers down here, you can see the correct answer is given by this one. And then here, an incorrect answer is given by INV volume. So that's why there's a score of 0 in this case. And then here, again, 0 is actually not possible for the correct answer. So if you look at our setup, all the numbers are positive and are positive integers. So if you look at our question, these are all, well, not all integers, but all positive numbers. So it's not possible to get a 0. Well, unless something goes to infinity in the denominator. But you saw that we controlled the size of these numbers with gen_rand_int. It only generated random numbers within a certain set of limits. So these so it's not possible to get a value of 0. So we know this answer must be incorrect. So that's why we have a score of 0 there. And then this one just takes the rate. So in this case, if the reader somehow thinks, or the person answering the question, if there's a possibility that they think the volume is equal to the rate, which is silly, with units are totally different. But anyway, if they did somehow think that, then it would be incorrect. So again, we specify a score of 0. And you have to be careful with these things. Sometimes it's possible because that your correct answer does turn out to have the same number as rate, just by coincidence, just because of the way the other variables have, let's say they were just ones or something like that, then it may well turn out that the volume is equal to the rate. So you have to be a bit careful when you are creating incorrect answers as part of your options. You want to make sure that it's not equal to your to the correct value either. And you can get quite creative and avoid that situation by in your question, or in your calculation for the variance, you because each one knows the values of all the other ones, you can write an if statement to tell you whether or not something is equal to the value you want to send out. So you can write full JavaScript in here. You can do as much as you want. You can even, inside of this function, you can define new variables. You can do whatever you like in here as part of generating the values for the variance. So you create all your variants here, the values for all the variant variables, and then that will go ahead and update the values used in the label, in the description if you have it, and then in the solution as well. So in the solution here, we want to be able to tell the user this is the right way to solve this problem. But in the face of all those variants, we want to see how to do that. So here you see we explain symbolically, and you can use MathJax. If you know MathJax, you can really write nice looking equations in here. But anyway, together with the equation, you can also show the calculation. So we want to show you multiply molar flow rate by conversion and divide by rate, and then you get volume. And so if you look here, let's go and get that thing wrong. So let's choose the wrong answer. Say practice, and you can see it's giving us the equation, but it's also showing us the calculation. So it's fed by 5 moles per second, so you have to multiply the 5 by the conversion 0.75 and divide by the reaction rate 8, and then that gives you your answer there. So it gives the person who's practicing this the feedback that they need to correct when they are not getting the answer right. So you see, it may also occur to you that isn't it quite a lot of work, and isn't it a bit too complicated to do all this? So it's not that it's too complicated. It's perhaps the interface needs to be upgraded so that we can navigate through this a bit more easily. But the point is, once you do this, it saves you a great deal of time afterwards, because you can generate many variants of these questions. So even from a small pool of questions, maybe even 3 questions, you can generate as many assessment questions as you want. Plus, accepting the case where you specify that you want to grade it, the system will go and automatically generate your scores and so on. So you can imagine, once you've set this up properly the first time, this can be used over and over again. And of course, one of the steps that we will be taking is to open this up, that you can submit your questions to a repository. And so you can, so the work you put into creating these questions can be can have value to other people, and of course it also means that you can access other people's content as well. So if other people have submitted questions for a similar concept or a similar topic, you can inherit those questions. So through this network of people collaboratively building questions, we can end up with quite a large pool of questions, and then using the settings and so on, we can generate any number of variants of these, and so our students can study as much as they want and practice as much as they want, and we can even use the same approach to generate our actual assessments and so on. All right, so that's quite a bit of detail, but that gives you a good sense for where we are going with this component in our NanoStream Blue suite of components.